Hello everyone, welcome all of you to this channel. I'm Dr. Ranjana and today we'll start class 11th chemistry. This lecture is the first lecture of class 11, that is basic concept of chemistry, and this chapter is very much important because obviously it contains basic concept which is required in every chapter. And we'll start with chemistry. What is chemistry? First of all, we'll discuss what is chemistry, branch of chemistry, then we'll start with other things. Okay, then what is chemistry? Chemistry is a science of atom and molecule, and you can define chemistry. It can be defined as the branch of science deals with properties, composition and transition, or you can say this changes takes place in matter. It deals with property of metal, composition of metal, and you can say chemical reaction, or you can say changes, physical changes and chemical changes takes place in the matter. Okay. Then this chemistry can be divided in different category, that is inorganic, organic, physical, biochemistry and all that. This, for example, this organic deals with the carbon compound, or inorganic chemistry deals with the compound containing the element other than the carbon, right? And the physical chemistry deals with principle and theories used in chemical reaction, right? The chemistry related with biological process can categorize under this biochemistry, right? Then come to, we'll start this chapter with a very basic thing, that is matter. What is matter? To start with matter. What is matter? The matter has some mass and it can occupy some space. Then it can call matter. Okay. This matter can classify in two ways, that is chemical classification and physical classification. It can on the basis of physical state, it can divide into three parts, three main category, that is solid, liquid and gas, right? It can divide into solid, liquid and gas on the basis of physical state, right? And you can define solid, liquid and gas easily. Let's start with solid. Solid is the substance having definite mass and definite volume. The force of attraction between molecule in the solid is very high, and intermolecular distance will be always low, right? And it is rigid and incompressible and all that. These are the properties of solid. You know that. You have read it in previous class. This liquid is the matter which has indefinite indefinite shape and right, and the intermolecular distance in between the molecule, the distance, intermolecular distance in the liquid will be larger than solid and lower than gas, and force of attraction in the liquid will be higher than solid, lower than gas. It is incompressible, but it has fluidity. It means flowing property. Molecule can move in the liquid. Okay. In the same way, gas can be defined as the matter has indefinite volume, indefinite shape. Intermolecular force in between the intermolecular force in the case of gas will be negligible always, and they can move freely in the given volume. Okay. And it can occupy whole volume in which it placed. Okay. And it is highly compressible and expandable. You can compress or expand gas. Okay. It can be compress or expand. These are the some basic property of liquid solid and gas. And one more thing is there, that is solid, liquid, gas can be interconvert into each other. For example, this solid, liquid, gas, it is very simple thing, but you should clear about that. That is the conversion of this solid into liquid is called melting. You know that conversion of liquid into gas is vaporization process. Conversion of gas into liquid is condensation. Conversion of liquid into solid is freezing process. And conversion of solid into gas, it is sublimation. And one more thing is left, that is conversion of gas into solid. This process is called deposition. Right? These phase can be are interconvertible, can convert into one type to another type of phase. Matter can change their phase and can interchange to each other. They can be interchanged to each other just by applying pressure or temperature, just by changing pressure and temperature. Then come to chemical classification. This matter can be classified chemically into two parts. That is, first one is pure, second one is mixture. What is difference between them? Pure has some pure substance have in this pure substance elements present in definite proportion. In this case, elements present in definite ratio or definite proportion. In mixture, this elements present in any ratio. Proportion in this case is indefinite. Okay, this pure substance can be divided into element and compound. These all are elementary things, but you should be clear. You should be very clear for that. What is element? These elements are the substance having same type of atom. Okay. This element may be atom, may be molecule. For example, N2, O2, argon, neon. These all are element, right? And what is compound? Compounds are the substance having different type of element. Okay, it has different element. It contain different elements in definite ratio, but in definite proportion. Okay, in this case, more than one element present, but in definite proportion. For example, CO2, NO2, KNO3. These all are compound. It means in this case, carbon and oxygen present in carbon dioxide in the definite proportion of the mass, that is carbon and oxygen present in indefinite proportion of mass of carbon and oxygen. Okay, then come to mixture. Mixture is the substance having the different element or compound in any ratio. Okay, and it can be divided into two parts, that is homogeneous and heterogeneous. These are the two types of mixture, that is homogeneous mixture and heterogeneous mixture. Homogeneous mixture, in this case, the molecules present throughout the homogeneity present throughout the substance. It means the molecule or any compound present in the mixture distributed uniformly. Okay, and in this case, in the mixture, the identity of component will be present. It means if you mix the sugar in water, it can form a solution, that is homogeneous mixture, but it can give you taste of sugar as well as water. It means it contains the property of sugar as well as water. Okay, for example, homogeneous mixture, your air is homogeneous mixture of different molecule. Blood, it is homogeneous mixture. Heterogeneous mixture, if you mix some sand and water, that will give you heterogeneous mixture. It cannot mix thoroughly in water. Okay, and molecules, the concentration of molecules present different in different part of substance, right? This is the example of mixture. Okay, then compound, you can also categorize the compound and element can be categorized into metal, non-metal, and metalloids. You can categorize the compound into covalent compound and ionic compound and all that, or you can say molecular compound. These are the this is the classification of matter, that is physical classification and chemical classification. Then come to next part, that is property of matter. Right? This property of matter may be physical property and chemical property. Right? What is the physical property? These physical properties can be determined without changing the identity of substance. If you measure the property without changing the entity, without changing the identity of the substance, then it is called physical property. And chemical property is the property which can be determined after changing the identity of the matter. Then it is called chemical property. For example, melting point, boiling point, mass, volume, these all are temperature. These all are physical property of the matter. And chemical property, acidity, how can any substance react with base, react with acid, basicity, reactivity with any substance. These are chemical property. It means if you want to measure these property, you will find that identity of that compound be changed. Okay, then this physical property can divide into two parts, that is extensive property and intensive property. What are these property? Extensive properties are the property which depends upon amount of substance, right? Amount of matter. And intensive property are the property which depends upon which is independent of the amount. Extensive property, what does it means? For example, if you measure volume present in a beaker, if you measure it is 1 liter, if you decrease the amount to half, if you take half of this amount, the volume will decrease to half liter. It means volume depends upon amount, that is volume, this mass. It is property that depends upon the amount. The extensive property depends upon the amount, right? But what about intensive property? If you measure the temperature of water present in beaker, this is T1. If you decrease the amount by half, if you decrease the amount of this water half, then you will find temperature will be same. It means temperature is the intensive property. This volume, mass, energy, internal energy, enthalpy, entropy, these all are example of extensive property. And intensive properties are the property which is independent of amount, that is, for example, temperature, density. If you want to measure density, it will be same. Diffractive index, right? These all are intensive property. Okay. Then come to another part, that is measurement. If this there is physical property, you have to measure that. Okay. And come to measurement, that is property may be quantitative and qualitative, and for quantitative property measurement is required. Property measurement is required, right? And for measurement it is required some common system is required, some standard system is required, and standard system of this measurement, for standard system of measurement is SI unit system. Because if you measure the length, you can measure it in kilometer, meter, millimeter, and all that, in inch and all that. But there is some basic unit. These are the unit which is required to express the any quantity. But some basic unit is required, and some SI unit. The SI unit are the some basic unit which is decided in 11th General Conference on Weight and Measurement, International Conference on Weight and Measurement. The 7 basic unit for measurement, 7 basic unit was decided, some 7 fundamental property for 7 fundamental property was decided in that conference. What are 7 basic unit? First one is kilogram, unit of mass. Second one is meter, unit of length. Third one is second, unit of time. Fourth one, ampere, unit of electric current. Fifth one, Kelvin, unit of temperature. Then sixth one, mole, unit of amount of substance. Sorry, amount of substance. And last one, that is seven, is candela. Seventh unit is candela. It is unit of luminous intensity. Right? These are the seven basic unit, and all other unit, the seven basic SI unit, and all other unit are derived unit. You can find the SI unit for any measurement, but it can be derived from these seven. Right? For example, density. For density, it is m by v, and for m, it is mass kg per. For volume, it is meter cube, kg per meter cube. It is the SI unit of density, right? Then come to some, for some conversion, you should know the prefixes in SI system. There are some prefixes in SI system that is required for conversion from one unit to the another unit. We'll start with 10 to power 1. It is desi, you know that, but it is just revision. Centi, milli, micro, then 10 to power minus 9, it is nano, pico, femto, then 10 to power minus 18, that is auto, then 10 to power minus 21, that is zepto, and 10 to power minus 24 is yocto. Yocto can be denoted by Y, it is Z, it is A, this one F, this one P, this one N, right? Micro can be represented as this one nu, milli is mi, centi is C, and deci can be denoted D. These all are prefixes in SI system, and in the similar way you can say it is deca. 10 to power 1, it is deca, that is denoted by dA. Then hecto, h, kilo, k, it is very common. Then 10 to power 6, that is mega, m, 9, giga, g, power 12 tera t peta p 10 to power 18, it is exa e, then zeta, zeta, z, and iota. You can remember them. Some is very important. These are not common, but up to tera, and in this case, up to pico or femto, it is important. Okay, right? Iota, zeta, exa, picta, tera, giga, mega, milli, kilo, and hectodeca. These all are prefixes which is used in SI system. Okay, then come to some common unit or some common measurement, that is mass and weight. Do you know the difference between mass and weight? Are they same? No. Mass is the amount of matter and weight is the force. It means if the substance having 12 kg mass, if mass is 12 kg, then weight will be is equal to 12 into 9.8 and it is force. Weight is actually force, right? Which is equal to mass into acceleration. That is, it is the gravitational force. This is the gravitational force of Earth. If you measure the same substance on Earth and other planet, then it will be different, and it is due to this part. Okay, because weight is the force, that is mass into gravitational force. It is on the Earth. It is the force exerted by the gravity. What is weight? It is the force exerted. Sorry, exerted by gravity on an object. It will increase with mass and it is constant. So we will consider generally weight and mass. We can use the word weight for the mass, but it is different from the mass. Okay, and what is SI unit of the mass is kg, right? Kg is the SI unit of mass. Then come to volume. Always there are some confusion in case of volume, because you know that most common, what is the most common unit of the volume? It is liter, right? For liquid, the most common unit is liter. 1 liter, 2 liter, and all that. And what is liter? It is 1 decimeter cube, right? It, or this 1 liter is equal to 1 decimeter cube. 1 liter is equal to 1000 millimeter, right? Milliliter. And 1 milliliter is equal to, or you can say it is equal to 1000 centimeter cube, right? 1 milliliter is equal to 1 centimeter cube and 1 liter is equal to 1 decimeter cube. It means for the solid, if you consider this is the cube, then 1 meter, 1 meter, and it is the breadth that is a three dimension, that is LHB should be 1 meter, then 1 and if it is cube and this one all is called 1 meter cube. 1 centimeter cube means all the dimension in centimeter. It means 1 centimeter cube means 1 centimeter into 1 centimeter into 1 centimeter. If you convert 1 meter cube into centimeter cube, then you should consider all the dimension in centimeter. Right? You can say that if for cube, you know that it is L, V, H, and it is length cube. It is always the dimension will be length cube, right? For cylinder, if you consider volume for cylinder, what is this? Pi r square into h. What will be the dimension? L square and L, that is L to power cube. If you see the dimension in the case of a sphere, volume will be always having same dimension, that is pi r cube. The dimension is r cube will be, that is the radius, and dimension of the radius will be always length. Or you can say for cone, volume for cone, solid cone, it can be given by 1 by 3 pi r square h is equal to this one. All have similar this dimension, and you can see that the volume for volume, this SI unit will be meter cube, and you can change this liter into SI unit easily by this conversion factor. Then temperature. The SI unit of temperature is Kelvin. We know that the unit of temperature is Kelvin, but common unit is centigrade and degree Fahrenheit. And how can you convert this centigrade into Fahrenheit and Kelvin? The relation between degree centigrade and Fahrenheit is C by 5 is equal to F minus 32 by 9, right? And is equal to K minus 273 divided by 5. This is the relation between Kelvin, centigrade, degree centigrade, and Fahrenheit, right? If you want to convert degree centigrade into Fahrenheit, you can use this part. If you want to convert Fahrenheit into Kelvin, you can use this part, and degree centigrade can be easily convert into the this Kelvin, that is Kelvin will be is equal to degree centigrade plus 273. For example, 1 degree centigrade will be is equal to 274 Kelvin, right? And you know that this degree centigrade may be negative value, but Kelvin will always have some positive value. Negative value for Kelvin is not possible at all. Okay, then come to another thing, that is conversion. Conversion of unit. Conversion of unit, it means you can convert one unit into another easily, right? For example, if you want to convert 1 kilometer into millimeter, it Means if you want to convert kilometer into millimeter, you can easily convert it by factors. That is unit factor method. If you want to convert kilometer into millimeter or picometer, this is the question of NCRT. That is, can you convert this kilometer, 1 kilometer into millimeter and picometer and all that, right? And what will be the process? You have to find unit factor. For example, if you want to convert 1 kilometer into millimeter, kilometer will be is equal to 10 to power 3 meter, right? Or if you want to convert kilometer into meter, unit factor will be 3 into meter by kilometer, right? And 1 millimeter is equal to 1 millimeter is equal to 10 to power 3 meter. If you want to convert meter into millimeter, that unit factor will be is equal to 1 millimeter. You have to take this part on the upper side. That is, if you want to convert meter into millimeter, then you have to multiply this factor in this way. That is 1 millimeter by 1 to power 10 to power 3 and all that. Okay, this is the unit factor. This is the unit factor, and you can convert easily by this method. For example, 1 kilometer is equal to 1 kilometer into, if you multiply this factor, this unit factor, it can convert into meter. 1 kilometer is equal to this much meter. And if you want to convert meter into millimeter, you have to multiply this factor. That is equal to, sorry, this is the meter, right? It can multiply by 1 millimeter divided by 10 to power minus 3 meter. If you calculate it, this will be cancel out. This meter and meter will be cancel out, and it will be 10 to power 6 millimeter. It means the answer will be 10 to power 6 millimeter. If you want to convert 1 kilometer into picometer, what will be the factor for picometer? 1 picometer, as you know that 1 picometer is equal to minus 12 meter. And if you want to convert meter into picometer, you have to multiply with this factor 10 to power minus 12 meter is equal to 1. You have to multiply with this factor. This is the unit factor for picometer. Then 1 kilometer is equal to, first you can convert into this meter by 1 kilometer. You can convert into meter by multiplying this factor. But then from meter it can convert into picometer easily, so that there will be no confusion in your mind. That is, this is the way. If you multiply them, this will unit will be cut out, and it will be 10 to power 15 picometer. It means 1 kilometer is equal to 10 to power 6 millimeter, 10 to power 15 picometer. This is the way in which these questions can be solved. It can, that is, you can convert one unit into another unit, one unit into another unit by just finding this conversion factor. And you can find easily, as you know, these unit values. Okay. In the same way, if you want to convert 1 milliliter into centimeter, if another question is conversion of 1 milliliter into centimeter cube, then you know that 1 milliliter is equal to 10 to power minus 3 liter, right? And it is equal to 10 to power minus minus 3 decimeter, right? Liter is equal to decimeter cube, decimeter cube, right? And if you want to convert this one in the centimeter, it is the you can convert easily. That is, milliliter is equal to 1 centimeter and 1 millimeter is equal to 1 liter. If you want to convert this 1 milliliter into decimeter cube, then you can convert it, because 1 milliliter is equal to 10 to power minus 3 liter and 1 liter is equal to decimeter cube square. Okay, decimeter cube. Oh, sorry, decimeter 10 to power minus 3 decimeter cube. As we know that 1 liter is equal to 1 decimeter cube. You can easily convert unit easily, and this type of question can be solved. Okay, then convert then come to another point, that is scientific notation. More thing is there, that is scientific notation. What is this? The digit can be represented in a proper manner, a proper way. This is the way of representation of digit, and this is 10 to power n. N into 10 to power n. N is the any number, right? And what is this n? This n, where n is equal to 0 to, it should be between 0 to 10. For example, if you want to represent this one in the way of scientific notation, you have to write it in this way. This is 2.34. This is the 234. It is not in between 0 to 10. You have to take it to 0 to 10. You have to shift decimal point, and you will find this one. And for this, you have to write number in this way. This is the scientific notation. It is the scientific way of representation of any number, where n is equal to, in n should be in between 0 to 10. Then come to two terms, that is precision and accuracy. What is difference between them? And what is this? Precision is the degree of closeness. It is the similarity between two or more measurement. It is the degree of closeness between different measurement. If you take two or more measurement, and the closeness of those measurement is called precision. For example, if you measure this one, any measurement is this in this way. So 1 1. If you take the measurement of length in this way, and this is the different value of different measurement, then it is the precise. If you want, it may be 10 to power point 0, then one time. It is the precise and accurate result. Any result required precision and accuracy both. What is this? The precision is the closeness between the different measurement. These measurement are close to each other. If you find the measurement in this way, that is 0.9, that is 0.13, that is 0.14. These are the measurement of the same length if these are the measurement taken by another person, and this is the result that is not precise. Measurements are not precise. This precision show the closeness. This is the degree of closeness of two or more measurement. But what is accuracy? What is this accuracy? Accuracy is the degree of closeness of the measured value and actual value, or you can say true value. If this is the true value which is measured, true value of this measurement, right, meter is unit, if this true value, then it is the, in this case, it is close to, these measurements are close to this true value, right? And in this case, this results show the accuracy also with precision. But these results shows neither precision nor accuracy. But if any, this is the person A, this is the measurement taken by person B, and if then another person who take the measurement, that is point zero 0.03, point zero 0.04, point zero 0.04, he take 5 times measurement, this person, the measurement taken by this person is precise because it is close enough, but it is not, if value of actual value in this case is 0.11, this is the actual value, and these results differ from actual value, and there is no accuracy. Accuracy is less in this measurement, but precision is more, and it happens in those cases. In these cases, the actually error present in method of measurement, right? We have to find the error in method only, because this is the precise result. Every time he get this type of result, but it is away from this accurate value. But any result in experiment, any result required precision as well as accuracy. Okay, then come to significant figure. These are the very simple things, and but it is important, and you should be clear in these things. Okay, significant figure, all digits that are known with certainty, and all number of significant figure, more number of the significant figure in the any digit and any number, it will be the more certain, right? All digit, what is significant figure? All digit that are known with certainty, right? And there is some rules to find the number of significant figure in any number. What are those rules? First rule is all non-zero digits are significant, right? Second one, the zero between non-zero will be significant, right? Then third rule is zero left to the first signif- first you can say non-zero digit will be non-significant. Fourth one is 0 right to the non-zero digit non-zero digit and sorry 0 right to the 0 right to the decimal point will be significant. Okay, and you can say counting number, which is certain actually. Counting number will be will have infinite significant figure. For example, if two number it has two or infinite significant number. If it is the this is the two digit present and it is the just 12, it can be written 12.0, 12.00, 12.000. So it is possibility of infinite significant, but you can consider it this two. Okay, for example, and it is beneficial if you write any number in the form of scientific notation, then you can count easily, right? If you write it in this way, this is a 10 to power 0, it is not significant, but it has three significant figure. If you write this one 342.3, right? If you write it in this way, this is the all non-zero digit, it has four significant figure. 5.03, it has three significant figure, 1230, between the number will be always significant. 0.0063, it has two significant figure because a 0 before first non-zero digit will be always insignificant. This will be 2, right? And in this way, you can count easily significant figure. For example, if this is the representation, then it is the 1, 2, 3. The decimal after decimal point 0 is always significant and it has three significant figure. These are the way in which you can count significant figure and all that. And addition, similarly, addition and subtraction part of the significant figure. In addition or subtraction, you have to represent the result in the same number of significant figure. Result should have minimum significant figure as present in any adding digit. For example, if you add this one plus this, then you have to give result in only one significant with only one significant. You can't represent it in the way. So this you can't represent the result with the four significant figure or five significant figure. Similarly, multiplication and division. In multiplication and division, the result can be represented then should be represented with the significant figure as present in minimum significant present in the any component, which is divider or divisor. For example, if you multiply this one 1.25, we will find 3.125, and you have to represent in with the only two significant figure. This will be the result, not this one, because you should represent the result with the minimum number of significant figure present in this part. Okay, this is the rule for significant figure, right? Then come to rounding off, right? Sometimes rounding off figures is required. Rounding off figure. What is this? If you want, if you want to represent this number with the only three significant figure, if you want this number with represent it with the three significant figure, then you have to take the three significant figure, but you have to round off. It means, what is the rule of round off? The if digit present after desired significant figure, if digit present after desired only one, sorry, if you want to represent with the three significant figure, then you have to write in this way. These are the first three significant figure, and if this one the digit present after desired significant figure, that is after 3, is more than 5, then you have to increase this last digit, preceding digit, with 1 by 1, and if it is less than 5 as it is 4, then you have to leave this digit as such. Okay, and if it is 5, then you have to increase preceding digit by 1 if it is odd, or leave as such if it is even. Let me just explain. If digit present after desired significant figure is more than 1, more than 5, then preceding figure increase by 1. If it is less than 5, then preceding figure will decrease by 1 after omitting that digit, and if it is 5, then preceding figure increase by 1 in case of odd, and preceding figure decrease by 1, sorry, remain same in case of even. We can see example. For example, if you want to rounding off, this is the number. If this number is this one, this is the 0.86, and if this number is this one, that is 0.85. These are the, and another number is 111.75. Okay, and if you want to round off this figure up to, you have to represent this figure up to 4 significant figure. You have to represent it in the 4 significant figure. Then what will be the representation? 112.8. These are the 4 significant figure, and this is the digit after this last digit is 4 and it is less than 5, that is less than 5. You have to put, you have to omit this digit, and you have to, you have to take this cities as same. Okay, then if it is more than 6, more than 5, then you have to increase this digit by 1. If it is 5, then, and this digit, this is preceding digit, is even, then you have to write as such by omitting this digit. And if this is odd, then you have to increase it by that. Okay, these are the explanation of this for rule. That is, digit present after last significant figure is, if it is less than 5, then you have to omit as such. If it is more than 5, then you have to increase preceding digit by 1. If it is 5, then it will increase by 1 in case of odd digit, and remain as such in case of even. It is the explanation of rounding of figure. Okay, then in next lecture we'll discuss theories, that is the ultimatomic theories and different theories, laws of chemical composition and all that. Okay, thank you.